Hi there, my name's Jack, and today I'd like to present my developed design for AENG201. So I'll start on the first page, which has the floor plan for the design on it. So first off, I'd just like to point out some of the regulatory constraints that had to be followed as per the low-rise, medium-density design guide. So first off, the setbacks, which are 5 metres from the front or eastern boundary to the front edge of the house, and then 2 metres from the southern end of the house to the southern boundary. It doesn't actually have to be 2 metres, it's specified 900, but I just wanted some extra room to be able to walk up and put a little garden down that side of the house. Also, the reason that it's located quite close to the southern boundary is to minimise any shading that might come across from the bounding northern property, and provide a nice sunny outdoor area there to the north of the patio for leisure. You can see in this floor plan, compared to the schematic design, that the plan has actually been flipped. So the bathroom is at the back, and the kitchen is now at the front, which also came about because of a regulatory constraint, which was that the bathroom window couldn't be facing the street front, so I wouldn't have been able to have a window at the front. So that's why that change has come about. Okay, so moving on to the second and third pages of the design, we have the elevations of the building. So just on this north and south facing elevation, I'll point out that you can kind of start to get a feel of the textures of the materials that are used to construct the building with. So we've got a concrete composite for the second skin facade walls, and a like Colorbond spandex roofing for the roofs, and a reclaimed timber cladding for the external walls and for the fences. You can also see there's some little angled awnings over those north-facing windows, which actually prevent the summer sun from being able to penetrate into those bedrooms and overheat them, but they do allow the winter sun, when it's lower in the sky, being able to get through and get some heat into those bedrooms. So in the east and west-facing elevations, you can see the kind of form of the main section of the house, of the roof. And also the solar panels that will be mounted on top, which are angled at 24 degrees, which was found to be the optimal angle of solar incidence for Wollongong. So moving on to the fourth page, I've included some construction details of some call-outs of different sections of the building fabric. So we've got a roof detail there, and a general external wall detail, and a detail of the internal thermal mass wall. And basically they just go through the different layers that these assemblies are made up of, and then states the R value that they were able to achieve in each of those sections. Alright, so the next slide here is a visual representation of the materials that are used in the construction of the building. So I'll point out the ones that I haven't already talked about. So we've got the high-performance aluminium window frames, which create a thermal break, impeding the transfer of heat either into or out of the building. We've got the precast geopolymer concrete slab, which is a lower embodied energy slab through the use of substituting the cementitious binder out for a byproduct of manufacturing, basically, called that's fly ash and blast furnace slag. And then the Bradford EnviroSeal wrap, which is used as the outermost membrane layer just before the first layer of insulation, and it allows the structure of the wall to actually breathe and moisture to escape after heavy rainfall events that the wall's exposed to. Okay, so these next couple of slides talk about the net zero energy strategy that has been developed to achieve net zero energy for this building. My strategy is really stemmed from the passive design principles. So I've talked about the location, the layout and the orientation of the house, the insulation of the slab, and the use of the slab as a thermal mass component to control the temperature within the house passively. Shading is really the main tool that is used to be able to control when the sunlight's going to hit or not hit that thermal mass, and therefore heat up or cool down the house. The next page talks about the energy production and energy efficiency of the house. So you've got the solar PV system on the roof, which provides the energy which will be consumed by the users, and then the embodied energy of the materials that go into building the house, and how that and the life cycle of those materials, how you balance that up together. Talk about the water management system and the heat recovery ventilation system for the air quality and the thermal comfort within the house. Then the last slide here is just some pictures of the 3D model that I made of the house. You just see everything come together there. See the different areas, how it's gonna how it's gonna look, I suppose, in 3D. Gives you a better picture of it. That's it pretty much. Yeah, thank you.